All right. Good day. How are you doing? So, we're going to work on domain 3 of the AWS Security Specialty exam. This is going to be infrastructure security. Another weak spot I had. What we're going to do is go over some of the questions, some of the answers, and why some are correct and incorrect. Right? We're going to go to sources. Remember, once we get through this, we'll be better prepared for that exam. So, before that, click like, share, subscribe, and let's go. So, question 15. A network load balancer was recently set up in a company's AWS infrastructure, but the target instances are not entering the in-service state. The security engineer was called upon to investigate the issue. After conducting a thorough investigation, the engineer determined that the health checks were failing. Which of the following could cause the health checks to fail? Select 3. So it looks like it's A, C, and F. Okay, so that's the target instances. Security group has no rules that allow traffic from the load balancer's IP addresses. The target instances subnet NACL does not allow traffic from the load balancer's IP addresses. And the target instances security group has rules that are not using the correct IP addresses to allow traffic from the network load balancer. Okay, so why is this correct? Why are these correct? So the load balancer health checks come from a static IP address. If the subnet NACLs block the IPs, the health check block these IPs, right? The health check traffic is dropped. And security groups must allow inbound traffic from the network load balancer IPs on the health check port. If security group rules reference the incorrect IP ranges, the instance won't accept the health check traffic. All right. So why are they incorrect? Let's go to the resources. All right. Network load balancers. Let's see if we can find health. Okay, so network for multiple reasons. Network load balancers can fail for multiple reasons. There are no healthy targets. Number of targets is less. Zonal shift or auto zones. So that's not quite what we're looking for. IP address types. Let's see this. You can use set of IPs with the following types. Must connect using the IPv4, right? Targets based on the IP address of the target group. And then the rest goes into IPv6, which we're not quite there, but it's closely related. Okay. Okay. And let's see, subnet traffic with subnets. Let's see. All right, so VPC with subnets, each has subnet traffic. All right, so the router sends traffic to the destination. NACL A determines traffic, which is determined by subnet 1. So this is required. This is talking about why the NACLs actually work, going from specific subnets. All right, so that's very crucial for it. So basics, each subnet in your VPC must be associated with a NACL. That's why. All right. If you don't explicitly associate it, the subnet is automatically associated with the default NACL. So you have to have that NACL has inbound rules and outbound rules. So these can be to either allow or deny, and it's not stateful, so you have to make it specific, right? So if the traffic matches a rule, the rule is applied, and don't evaluate any additional rules, right? So you have to create this in increments, and you have to look at it. See, NACLs are stateless, so that information, which means information about previously sent or received traffic, is not saved, right? Which it is with security groups. So that is why the security groups one is correct. So let's go a little bit more into specifics here. We'll save this. All right. So incorrect answers. All right. Why are they incorrect? So the target instances, subnet NACL does not allow traffic from the load balancer security group. Well, so NACLs don't recognize security group IDs. That's the basic, right? Excuse me for this one. All right. Get this open. Let's see here. Okay. So NACLs are stateless. We went over to this one. So this is in contrast to how security groups work. Security groups are stateful, which means that security information about previously sent or received traffic is saved. So if a security group allows inbound traffic, it'll automatically allow outbound traffic. Okay. What is the next one? Okay, so the target instances security group does not allow traffic from the load balancer's NACL, right? So security groups cannot reference NACLs. They can only reference IP addresses, another security group, or prefix lists. Okay. Okay, specific allow for security group. Where is this going to be? Okay, so look, so use the components, the protocol, the ports, source destinations. This will be important. So prefix length for the IP addresses. Here's a CIDR block right here for a range, and this is for IPv6. And then the ID of a prefix. So this is the managed prefix list and the ID of a security group. Okay. All right, and then the last one, target instances security group is not using the DNS name of the load balancer to allow traffic from the load balancer. All right, so security groups do not support DNS names as valid sources or destinations. Only IPs, security groups, or prefix lists. Boom. Okay, so remember this. For these options, for the security group, health checks will be blocked if the load balancer traffic isn't explicitly allowed. For NACLs, for traffic will be dropped before reaching an instance if it blocks the load balancer's IP. And if the security group has the wrong IP, then that means the misconfigured rule won't match the load balancer packets. Okay, so remember those and we'll move forward. All right, question 20. Corporation is looking for a solution that provides automatic scanning of operating system and programming language package vulnerabilities for all its container images stored on ECR. The images should only be scanned once when they are pushed onto the repo. Which of the following options is the right fit given the requirements? So it would be B, opt for enhanced scanning and specify a filter for a scan on push. So why is that correct? Okay, so enhanced scanning integrates inspector with container registry, ECR, and it supports detection of both operating system and programming language package vulnerabilities. And you can configure scanning frequency with filters and scan on push triggers, scan immediately when an image is pushed. All right, so let's go over here. Push. With enhanced scanning, you can choose repos. Okay, let's see if we can find this. Let's see. So, okay. So inspector supports scanning for specific operation systems. Inspector can scan your image, but there is a cost. Okay. Uses IAM roles. When you turn on enhanced scanning for your private registry, inspector only recognizes images pushed to ECR in the last 30 days or pulled in the last 90 days. Older images will have scan eligibility status. So all images pushed to ECR after enhanced scanning is turned on are continually scanned for the configured duration. By default, the duration is a lifetime. Okay, so you would opt for that enhanced scanning and be okay. Okay, so basically, why is this done? Enhanced scanning integrates inspector with ECR and supports detection of OS level vulnerabilities, programming language package vulnerabilities like Python, Node.js, or Java. And you can configure scanning frequency with filters like scan on push, right? Which, let's go back and push. Okay, you can separate filters for scan on push and continuous scanning, right? Or you can have continuous scanning, right? So that's ongoing scanning as new CVs are released, right? So this only requires, this question only talked about the one-time scan. So scan on push is the correct frequency that addresses this, all right? So let's go back and see why the other ones were incorrect. All right, so opting for enhanced scanning and specify a filter for continuous scanning. All right, well, so continuous scanning goes beyond the scan on push scope, right? And it continues to monitor for newly released CVEs. So the scenario only asks for scanning once when the image is pushed. So it makes continuous scanning an overkill, right? And it's not cost efficient. Okay, so let's see, opt for enhanced scanning and sets a manual frequency. So manual frequency is not supported with enhanced scanning. So manual scanning is only available with basic scanning. And AWS explicitly states that enhanced scanning requires filter-based automation for a push or continuous. Okay, so let's see. Aren't supported. See, right there. Okay. All right. And then opt for basic scanning on push filter. Okay, so basic scanning only supports operating system vulnerabilities using, I can't remember the engine. It does not support programming language package vulnerabilities, which is a requirement in the question. Okay, so let's see here. Okay, so enhanced scanning here has this operating system and programming languages, and then scan on push and continuous scanning. So basic scanning, right, has two versions: native based scanning, which is generally available, so all users can use this, and then Claire. Claire is the engine. Okay, so uses Claire project, and so Claire's deprecated. All right, so that's no longer going. Okay, so basic scanning is powered by open source Claire, and it only supports operating system, right? So you can choose for enhanced or basic, but this one requires enhanced. All right, so for enhanced scanning and scan on push, that is the one that meets requirements to scan once on push and supports operating system and code package vulnerabilities, which you can see here. Okay. Okay. All right. A mid-sized company stores sensitive data on an elastic block store, volume attached to an EC2 instance. To ensure data durability, the company also replicates the sensitive data to an S3 bucket. Both the EBS and S3 are encrypted using the same key management service and customer master or key management service customer master key. The security team at the company has noticed that the CMK has been deleted. A former employee had set the key for deletion before leaving the company. As a security specialist, what do you suggest to access the data? So the answer is B, right? So copy the data directly from the EBS encrypted volume before the volume is attached from the EC2. Okay, so why is this correct? So when an EC2 instance attaches an encrypted EBS, AWS decrypts the volume's data key and stores the plain text data key in hypervisor memory. This in-memory data, this key remains active until the instance is stopped or the volume is detached, even if the KMS key is deleted. Okay, so where are we going? Okay, so deleting it is destructive, deletes this. You can no longer decrypt it unless, so should delete this. Let's see about the waiting period. So there's a waiting period to delete a key. All right. Special considerations. Maybe it's here. Why am I not finding? Let's see. You can only delete the key. You cannot delete the managed keys. You might want to know, so sorry for text. All right. I'm not finding it here. Okay, so the waiting period might be up to 24 hours longer than you scheduled. So during the waiting period, the KMS key and status is lifted, is pending deletion, right? So KMS does not rotate the key material after the waiting period. KMS deletes the KMS keys, alias is all related metadata. All right, so where is the specifics? Let's see if it's here. Okay, will be used, be decrypted only in HMS. The return ciphertext is never stored in KMS. We're looking for it. We're looking for it. We want to find that specific information. Let's see. Okay, so you are required. Let's see. Pre-update. You cannot change. Hmm. Encryption by default. So where is this? I'm trying to find this because all right. So I know this is why it is, but you can attach both encrypted volumes to an instance simultaneously, and then snapshot or volume you can associate with a key. Hmm. Okay. You cannot audit keys and you cannot delete them. Oops. Schedule key deletion canceled. Let's see if it's here. You can cancel the key deletion while it's still pending state. You can cancel it, enable and disable keys. No. Hmm. All right. Well, maybe it'll get more clarity when we go to the one that talks about what do you call it? The incorrect answers. Let's go for that. Let's see that. All right, because that sometimes can help you go for this. Okay, so log in as the account root user to just restore the deleted key. Okay, so once a CMK is deleted, it's permanently and irreversibly removed from AWS. Even the root user cannot restore a deleted key, and only scheduled deletions can be canceled during the waiting period. So that's something to consider, which we briefly walked over. Um, let's see. Yeah, which is confirmed right here. Okay. The other one, let's see. So take a snapshot of an EBS encrypted volume before it's detached from the EC2. So while the volume is still attached, you can read data. However, creating a snapshot requires re-encrypting data using the original CMK, which is now unavailable or deleted. So the snapshot operation will fail. Ah, okay. Let's see. Okay, so snapshots created from encrypted volumes are automatically re-encrypted using the same KMS as the volume. Boom. So that confirms that portion. We can work backwards from that one. All right. And then I think that was, oh, and raise a ticket with AWS support. I mean, that's not going to be correct, right? So why is that incorrect? So AWS support cannot recover deleted CMKs, even if the deletion was accidental. So once deleted, all data encrypted with that key is permanently unrecoverable, unless decrypted data was cached or stored somewhere else. Okay. Let's see. So key deletion is final, right? So you should only, okay, here you go. You should only delete a key when you're sure you're not going to use it anymore, right? This might have the full answer. Okay. You can only schedule a deletion of customer keys, and you might choose to delete it for this reasons. So this covers it. All right. So remember for this, right? The EC2 holds that encrypted data or decrypted data key in the memory, and you can use that to copy the data directly from the encrypted volume before the volume is detached from the EC2 or stopped. All right, let's go to the next one, 33. A cybersecurity company is using AWS Systems Manager, Sessions Manager to manage EC2 instances in US East 1 region. A user is unable to connect to a new EC2 that runs Amazon Linux 2 in a private subnet in a newly created VPC. The systems admin has confirmed that the new EC2 has the correct IAM instance profile attached. As a security specialist, what would you attribute as the root cause behind this issue? So this is saying B, okay? The EC2 is in a private subnet and does not have the com.amazonaws.us-east-1 SSM messages VPC endpoint for sessions manager, okay? So why is this correct? So for instances in private subnets with no internet access, you must configure interface VPC endpoints so that the SSM agent can communicate with the systems manager service. The SSM messages endpoint is required to create and delete sessions channels with the sessions manager service, right? So let's go over here. Let's see this. Okay. So to manage this without Systems Manager, to use this, you create an IAM profile for Systems Manager, verify it's installing the instance, create an IAM instance profile, attach the IAM to your instance, open the EC2, and then there's going to a security group. Okay, so VPC endpoints map to a specific subnet. You select multiples, you create it, and then one is created for each subnet. Okay, so for service name, com.amazon AWS, and then that region at US each one, right? And then you create an interface endpoint for the policy for Systems Manager. They don't require DNS, all right? And for the Systems Manager endpoint, you would select that again for the service name. And for EC2 messages endpoint, you'd select the EC2 messages for the service name. Okay, so remember, Systems Manager lets you connect to EC2s without SSH, without bastion hosts, without opening inbound ports. For private subnets without internet gateway or NAT gateway, the instance cannot reach SSM endpoints over the internet. So VPC endpoints must be used. And it's specifically that com.amazon.aws.com, then the region, and then SSM or SSM messages or EC2 messages. Okay? And SSM messages is just for SSM. And without the SSM messages endpoint, the SSM agent cannot open a session channel with the control plane. Okay? So why are the other answers incorrect? So let's see. The EC2 key pair associated with the EC2 is invalid for the given user. Okay, so Systems Manager does not use SSH key pairs at all. It uses IAM permissions and the SSM agent, not EC2 key pairs. The key pair only matters for SSH-based access, which this is not. Okay, let's see. There's no bastion host to facilitate connection from the Systems Manager Session Manager. So a bastion host is not required when using Sessions Manager. Sessions Manager provides direct access via SSM APIs and does not route through a bastion. Okay, and then the EC2 instance security group has no rule to allow inbound on port 22. Sessions Manager does not use SSH or port 22. So there's no inbound security group rule required for Sessions Manager. The only networking requirement is outbound as HTTPS to SSM endpoints or interface VPC endpoints. Okay, so when it's missing SSM messages on the VPC endpoint, you need to solve that because it's required for Sessions Manager in private subnets. Okay. All right, so next question. An open banking system enables secure open API integrations for financial institutions. The banking system needs mutual TLS, MTLS authentication as part of its security standards. The application will be hosted on an Amazon EC2 server. The system has specific security compliance rules that need the server to terminate the client's TLS connection. So, as a security engineer, how will you configure this requirement to support MTLS if a load balancing service is needed for the instances? So we talked about this a little bit earlier or in the previous one. B, create a TCP listener using a network load balancer and implement MTLS on the target. So why is this correct? Okay, so MTLS, mutual TLS, requires the server to verify the client certificate. If your compliance rules require the EC2 instance itself to handle the TLS handshake, then the load balancer must not terminate TLS. And a network load balancer using a TCP listener is ideal because it operates at layer 4, the transport layer, and forwards encrypted traffic directly to the EC2. And MLS termination must happen on the EC2, not at the load balancer. So let's see if we can get some source documentation. Okay. Let's see. Okay. So network load balancer supports TCP. Looks like let's try the listener. Let's see, TLS. So listener configuration, use a TLS to offload the work of encryption. You must ensure the targets decrypt TLS traffic instead of the load balancer, instead of creating a TLS listener. Let's go down here. Okay, so Yeah, so TLS listener, you must have at least one certificate on your load balancer. The load balancer uses a certificate to terminate the front end connection and then to decrypt requests from clients before sending them to the targets. Okay. So for MTLS support, create a TCP listener instead of a TLS listener. And the load balancer passes the request through as is, so you can implement MTLS on the target. That's it. Those are two. All right. So why are the other ones incorrect? We'll go over here. Let's see. Okay. So configure an MTLS listener on an application load balancer and enable mutual TLS. Okay, so application load balancers support MTLS termination at the load balancer, right? But in this question, the requirements for the EC2 server to terminate the client's TLS connection, not the application load balancer. If MTLS is terminated at the load balancer, the backend EC2 instances receive unencrypted traffic. That's what that TLS is for. This violates the compliance requirement, okay? And this will go through it here. Go search for this page. All right. And then the other question, let's see. Network load balancer support, TLS renegotiation, and mutual TLS authentication. So MTLS and configure a TLS listener for a network load balancer. So network load balancer TLS listeners support server-side TLS termination, but not mutual TLS authentication or TLS renegotiation. So you cannot configure the client certificate verification step for MTLS at the load balancer TLS listener. So this setup would not fulfill MTLS's security compliance requirements, meaning that the traffic would not be encrypted, right? That's the bigger thing, right? So TLS listeners on network load balancers do not support mutual TLS. Let's see if we can find it here again, which I think we found earlier. No, we found it on the listener page. That's okay. Okay, so configure a TCP listener on an application load balancer. Okay, so load balancer does not, an application load balancer does not support TCP listeners. Application load balancers operate on only at layer 7, supporting HTTP and HTTPS protocols. MTLS on an application load balancer is only possible through HTTPS, and that too requires termination at the application load balancer. All right, so we'll see. We have this here. So you see all this. See mutual TLS. Oops. We'll open that in the second page. Okay, so you see all this. Mutual TLS operation supports HTTP and HTTPS in both pass through and verify, right? And then we can go for that one. Yeah, this is all your TLS information here. All right, so mutual TLS here. When you use application load balancers, since the whole client chain is target using HTTP headers, right? We use mutual TLS verify mode. Application load balancer performs client certification for clients when a load balancer negotiates it. So this is saying it terminates there. This is what I'm seeing here. All right, and it does have certificates, does have certificate pass through, but the HTTP and HTTPS is what's going. That's what's cooking. All right. All right, so remember for this, TCP listener on a network load balancer with MTLS as the target, right? This allows mutual TLS, that means encryption in transit, to terminate on the EC2 server. All right, let's go to the next one. Financial services company is running an Amazon RDS for MySQL database instance in a virtual private cloud to store sensitive customer data. Due to strict security policies, the company has implemented a VPC that does not allow any network traffic to or from the internet. Security engineer at the company wants to use Secrets Manager to automatically rotate the DB instance credentials for increased security. However, due to the company's security policy, the engineer is not allowed to use the standard Lambda function provided by Secrets Manager to rotate credentials. To address the issue, the security engineer deploys a custom Lambda function within the VPC. This function is responsible for rotating the secrets in Secrets Manager. The security engineer also edits the DB instance's security group to allow connections from this custom Lambda function. However, when the function is invoked, it is unable to communicate with Secrets Manager and cannot rotate the secret. What Which of the following options will address the given scenario? So it says B, add a VPC interface endpoint for Secrets Manager and configure the Lambda's functions subnet to use it. Okay, so why is this correct? So to allow a Lambda function inside a VPC to access Secrets Manager without the internet, you must configure a VPC interface endpoint for Secrets Manager via private link. So this avoids the need for public IPs, NAT gateways, or internet gateways. Boom. Okay. So let's go over here and get this link. So, okay. So Secrets Manager is a regional AWS service. And when a Lambda function runs inside a VPC with no internet access, it cannot run Secrets Manager unless it accesses Secrets Manager via a VPC interface endpoint, right? So by creating the interface endpoint, remember that com.aws, Amazon AWS dot whatever the region is, dot Secrets Manager, Lambda can communicate privately and securely with Secrets Manager without public internet access, NAT gateway, or direct connect. Okay. So just basics on Secrets Manager. Let's see, this might be better. There we go. This will be good. Okay, so deploy those resources. Let's see, private. Okay, so there are quotas on private link that talks about it. You can use a VPC endpoint to connect to services powered by private link with many services listed. And then for service name, you can find out more here. And then, okay, so you can select the service name for S3, configure for private DNS, enable private DNS. Now that's a little bit different than what I'm looking for, but it's here. But really what you're talking about is create the endpoint, the service name via private link, and in the VPC, select the VPC, you'll choose to access that service. This is it right here. This is it right here. And you could do additional things, right? So if you select the service name and you want to configure private DNS support for additional settings, this is where this would be, right? Okay, so why are the other ones incorrect? Okay. Create a NAT gateway in the VPC, configure the Lambda function to use NAT gateway. All right, so while using a NAT gateway in a public subnet can allow outbound internet access from subnets, it exposes traffic to the internet, which violates the company's security policy. So VPC interface endpoints are the preferred secure method for accessing AWS services like Secrets Manager from private subnets. All right, let's see if we can find that here. Yeah. In your AWS, and yeah, network interface. The network interface is Lambdas. All right, so it's not quite here, but we got that first portion to get that. All right, create a VPC peering connection between the VPC and Secrets Manager and configure Lambda function subnet to use it. That's not going to work. So VPC peering connects two VPCs, not a VPC to a secret service like Secrets Manager. All right, so AWS services are not part of customer-owned VPCs and therefore cannot be connected via peering. All right, and let's see if we can find some peering limitations. Yeah, this is VPC to VPC, so you can see that here, but it's not going to go there. That's just insufficient. Create a direct connect connection between the VPC and Secrets Manager and configure the Lambda's functions. Subnet to use it. That's not. Direct connect is designed to link on-premises data centers to VPCs, not to connect VPC to a specific AWS service. So it can't be used to directly connect or access Secrets Manager unless it's combined with a VPC endpoint, which would still be required. Okay. So remember for this one, you need a VPC interface endpoint for Secrets Manager to connect privately without public internet access. Okay, so it enables private, secure access to Secrets Manager, which is an AWS service. All right. Okay. So at the corporation, the IT team recently discovered a security loophole that could potentially allow unauthorized access to sensitive data. To fix the issue and ensure the protection of their company's information, the team wants to establish and delete the ability to delete an AWS customer master key within a 24-hour time frame. This will prevent the key from being used for encrypt or decrypt operations and keep their data secure. Which of the following would address this? So this is saying D, implement the KMS import key function to perform an immediate delete operation. Okay, so why is this correct? So when you use the KMS import key feature, you control the key material. You can delete the imported key material at any time, which makes the KMS key immediately unusable for cryptographic operations. So the key enters a pending import state. Okay, so being that you control the material, you can set an expiration time for the key material, or you can delete the key material at any time, which makes the KMS key immediately unusable for cryptographic operations, right? So once the key material is deleted, the KMS enters that pending import state and cannot encrypt or decrypt until new material is imported, okay? So let's see. So you probably find this here. So this is more about its supporting types. You cannot import key material into KMS keys and custom key stores. That's not what I'm looking for. Import key material. Reimport. There you go. So we talked about this one, I believe. Okay, so deleting is temporary and reversible. In contrast, deleting a KMS key is irreversible. Okay, so reporting this. Okay, so deleting the key material is temporary and reversible. Depends on this. Imported key material. Let's see if this covers it. You can delete the imported key material from a KMS key at any time. Also, when imported key material with an expiration date expires, KMS deletes the key material. In either case, when the key material is deleted, the state of the key changes to pending import, and the KMS key cannot be used in any cryptographic operations. Okay. So, along with disabling, deleting key material can be used as a strategy to quickly but temporarily halt the use of KMS key. Boom. So those two things would get it. All right, why are the other ones incorrect? Okay, so utilize the scheduled key deletion feature in KMS to set the minimum wait time. You can't do that. So AWS forces a mandatory waiting period of 7 to 30 days for scheduled deletion of customer managed keys, right? So there's no way to reduce this wait to under 24 hours. You cannot access or use the key after deletion, but deletion itself is not immediate. We've already gone over this a little bit. Use the manual key rotation feature within KMS to instantly create a new CMK. So key rotation changes the key material for a given CMK, or it allows you to create a new CMK and rotate the alias to it, right? So it does not delete the key or prevent access to encrypted data. So rotated keys remain available to decrypt older data encrypted with previous versions. And then, let's see, alter the CMK to immediately stop any services from utilizing CMK. Yeah, aliases are just pointers to keys. So changing or deleting an alias doesn't affect the underlying key or its usability. So any service or user referencing the CMK directly by ID, so not by an alias, they can still use it. So altering alias does not prevent the use of the CMK. So the best way to do this, use the KMS import key for new key material, and then delete the other key material. So when you delete that key material, when you import that key material, it deletes the other key material instantly, and the key becomes instantly unusable. Okay, so the next question. Okay. Okay, question 61. An AWS service present in AWS account 1 is exposed to AWS account 2 using VPC private link. The network load balancer in account 1 is configured and is accepted the connection. While this data is seen leaving from the load balancer, the client side is not getting the transmitted data. What steps should be taken to troubleshoot this issue? This is saying D, ensure that the security groups and NACLs in both VCs allow traffic. Okay, why is this correct? So private link uses interface endpoints that are ENIs in the consumer's VPC. And then traffic will be routed privately over the AWS network to a network load balancer in the service provider's VPC. So if the security groups or NACLs do not allow inbound, outbound traffic, like to or from those elastic network interfaces, the connection may be accepted, but the data won't flow. So this is a common root cause when network load balancer shows outgoing traffic, but the client side receives nothing. All right, so let's go to, let's see if we can find this. It's a private link. Let's see. So where are we going here? Service state. You can have this showing the endpoints are created, resource configurations. You need the VPC endpoint, the interface, the load balancer, and endpoints. So if an endpoint supports IPv4, its endpoint network CNI has IPv4 addresses, a VPC for IPv6. Okay, so you can describe that endpoint and endpoint states. That's not there. So traffic is sent to the endpoint using a connection between the VPC and the service. Traffic and an endpoint service resource stays in the network without traveling over the public internet. Okay. And then service provider adds permissions so it can access it with this. And it'll share resources through RAM, which makes sense. Now I want to see. So you see that VPC endpoint, that VPC. That's the architecture. Let's see if we can find it in here. Okay, so here's a good question that's in the AWS blog. So isn't log, it's not going to help you for troubleshooting. Ensure that okay, so this is, all right. Ensure that the security groups and NACLs in both VPCs allow traffic. That's it. Set up another VPC to troubleshoot from there too. That's a good one. Okay. So this will be information to diagnose this. So VPC flow logs, that would be a way you could start looking at it to make sure you have connectivity so you can see, help you with a number of tasks, diagnosing overly restrictive security group rules. There you go, security groups. Monitor the traffic. So you're basically going to monitor that traffic to make sure the security groups are actually letting stuff through. That would be the way that you could start capturing to diagnose it and then see what's actually working correctly as it goes. Okay, so why are the other ones incorrect? Okay. Enable VPC flow logs to capture detailed info about the traffic going to and from the network interfaces to the load balancer. So VPC flow logs do not capture traffic between a VPC endpoint, so private ENI and the load balancer. So you can't rely on flow logs to investigate the traffic flowing over private link. Ooh, so maybe I wasn't quite correct. So you can log it. So you can get some diagnostics, but you can't overly rely on it. Okay, that's interesting. So configure a gateway VPC endpoint instead of a private link to access services across account. Okay, so gateway endpoints only support S3 and DynamoDB. So it can't be used for custom services or cross-account integrations via like a network load balancer or private link. So this is, you can't do this. You just can't do this, right? It's an option, and it is not an option. Okay, use CloudTrail to capture detailed information of calls made to the VPC. So CloudTrail records API level activity, such as creating a VPC, modifying route tables, but it doesn't capture actual network traffic or data flow. So it's not useful for troubleshooting this. All right, so remember, check the security groups and the NACLs. You might be able to check the flow logs, but it's not guaranteed. But because it doesn't capture private link or network load balancer traffic. So you're going to have to check those security groups or the NACLs to make sure that the subnet level, or sorry, the instance group, make sure the instance, the subgroup for this instance for the security group and subnet for the NACL are correct for inbound and outbound. Whew, excuse me. All right, next question. All right, a company has moved its business critical data to an Amazon EFS. That's a file system. File system which will be accessed by multiple EC2s. Which of the following would you recommend to exercise access control so that only the permitted EC2s can read from the EFS? So this is saying B and E. So use a VPC security groups to control the network traffic to and from your file. That makes sense. And then use an IAM policy to control access for clients who can mount your file system with the required permissions. So why is this correct? So security groups act as firewalls to the EC2 and EFS mount target levels, right? So this controls network access precisely. EFS IAM authorization lets you define which IAM principals can mount the file system. And when combined with EFS access points, you can enforce user-specific permissions, okay? So you can limit it to, let's say, NFS port 2049, only from a specific instance or CIDR. All right. And then for the IAM policy, you can have whether a client like an EC2 with a role can perform any actions like client mount, client write, client root access, right? This is an authorization layer, not necessarily an access layer. So why the other answer is incorrect? Okay. So use a NACL to control network traffic to and from. So NACLs operate at the subnet level, not on an instance level. So these are stateless, and although technically it's possible, it's less granular and harder to manage than security groups. Okay, and security groups are the recommended mechanism for managing access to EFS for mount targets. Let's see, set the IAM policy root credentials to control and configure clients' access to EFS files. So IAM root credentials are never recommended for operational use. So there's no concept of an IAM policy root credential to control EFS access. Only IAM roles or users should be used with the appropriate permissions for access control. Okay, and then let's see, guard duty to curb unwanted access. So guard duty is a threat detection and monitoring service, not an access control mechanism. It can detect suspicious activity, but it can't enforce access rules to EFS or any other service. Okay, so the two things, the security groups to control traffic to EFS, and then IAM policy for EFS access, right? So this manages traffic and then permission and authorization. Okay. So next question. So the origin of a CloudFront distribution requires that all requests must include the authorization header. That this mandates that CloudFront distribution to forward the authorization headers to the origin. As a security engineer, how do you configure a solution to address this? So this is saying create a cache policy, then associate the cache policy with the cache behavior that must forward the authorization header. All right, so why is this correct? The authorization header must be part of the cache key. So CloudFront forwards authenticated requests to the origin and avoids serving cached responses to unauthorized clients. So you must use a CloudFront cache policy that explicitly includes the authorization header. So authorization header must be forwarded as part of this, right? You could do this via custom cache policy that explicitly includes the authorization header, but the origin request policies cannot forward the authorization header because CloudFront will reject it with a 400 error. Okay, so let's see if we can get some supporting documentation. Okay, so create a cache policy and then associate the cache policy with the cache behavior. If caching is turned off, then you want to use all viewer and edit it. And if the caching is turned off, then use an origin request policy. So this is right here, create a cache policy, going here. Let's see if we can get something else. This is basically how cookies work. I mean, but internally. Yeah. Okay, this is good. Why the other one's incorrect? Okay. Okay, so configure CloudFront origin request policy to forward the authorization header. So you cannot use origin request policies to forward authorization headers. Attempting to configure this results in that 400 bad requests because it is disallowed for security reasons. Okay, so you can't use origin request to forward authorization headers per AWS. For Amazon S3, Caching based on the authorization header is supported only when options responses are cached. Okay, so S3 origins do not support caching responses that use the authorization header. Even with options responses, authorization-based cache behavior is not supported with S3. And then configure the CloudFront viewer request policy to forward authorization header. So the option is fictional. There's no such thing as viewer request policy in CloudFront. CloudFront supports cache policies, origin request policies, and response header policies. Okay, so why is this correct? So what is it? You create a cache policy and forward the authorization header. Okay, this is the correct way to forward it. And it's only one of the 3 ways allowed. Okay, and I think that might be all right. All right, so question number 22. A corporation is looking for a solution that provides automatic scanning of operating systems and programming language package vulnerabilities for all its container images stored on ECR. Images should only be scanned once. Oh, we already did this. So opt for enhanced scanning and specify a filter for scan on push. Okay, so why is that correct? So enhanced scanning integrates with Inspector to detect operating system and programming language package vulnerabilities, right? The other ones do not do that. One, let's see, manual frequency, that's not what it's asking for. Basic scanning does not do that because it requires enhanced scanning with a specific filter for continuous scanning. We don't want to do continuous scanning. Okay. All right. A business maintains its business critical customer data on an on-prem system in an encrypted format. Over the years, the business has moved from using single encryption key to multiple encryption keys by dividing the data into logical chunks. With the decision to move all the data to S3 buckets, the business is looking for a technique to encrypt each file with a different encryption key to provide maximum security to migrated on-prem data. How will you implement this without requiring the overhead of splitting the data into logical groups? So it's going to be C. Configure an S3 to hold all data. Use server-side encryption with S3 managed keys to encrypt the data. So why is this correct? So S3 automatically encrypts each object with unique data keys behind the scenes. Each data key are themselves encrypted with a master key that is rotated regularly. So this meets the requirements of encrypting each file with a different key without needing to split the data or manage the keys manually. So why are the other ones incorrect? So let's see, store the logically divided data into different S3 buckets, use server-side encryption. All right, so SSE, so server-side encryption already uses per object encryption keys. So creating multiple buckets is unnecessary. It's overhead, it's additional overhead. And yeah, it's too much. So multi-region keys for client-side encryption and the S3 to generate unique keys. So this question requires server-side encryption, right? This option involves client-side encryption, which shifts the responsibility to the customer. It also introduces key management complexity and is outside of the desired design. Configure a single S3 to hold all data. Use SSE KMS and use encryption. Okay, so encryption context does not generate different keys. It's used as additional authenticated metadata for verification during decryption. So SSE KMS does not create a unique CMK per object. Instead, it uses the same CMK with unique data keys per object. So it doesn't accomplish it. Okay. Next question. Okay. Mid-sized company stores sensitive data on an EBS volume attached to an EC2 to ensure data durability. The company also replicates the sensitive data to an S3. Both the EBS and S3 are encrypted using the same KMS customer master key. The security team at the company has noticed that the CMK has been deleted. So we just went over this one too. Copy the data directly from the EBS before the volume is detached. Okay, why is this correct? So the EC2 attaches this, right? And AWS decrypts the volume data key and stores the plain text data key in memory. The in-memory data key remains active until the instance is stopped or the volume is detached. Even if the KMS is scheduled for deletion, remember that 7 to 30-day window, or has already been deleted, right? So as long as the instance is running and the volume is attached, you can copy the data using the active session. Okay, so why are the other ones incorrect? Log in as the AWS root account and restore that. Well, once a key is deleted, it can't be restored, not even by the root user. Raise a ticket, that's not going to, AWS cannot recover a deleted KMS key. take a snapshot of the EBS. Okay, so creating a snapshot requires using the same KMS key to encrypt the snapshot. If the key is scheduled or has been deleted, the snapshot will fail. Okay. So let's go to the next one. Okay, so we've done this, open banking. So I'm doing this from, okay, let's just go through it. Open banking system enables secure API integrations for financial institutions. The banking system needs mutual TLS authentication as part of its security standards. The application will be hosted on EC2. The system has specific security compliance rules that need the server to terminate the client's TLS connection. As a security engineer, how do you configure this requirement to support MTLS if a load balancing service is needed? So this is saying create a TCP listener using a network load balancer and implement MTLS on the target, right? So for strict compliance, requiring the EC2 to terminate the TLS connection, like in an open banking system, you must pass the TLS through the load balancer without decrypting it at the load balancer level. So a network load balancer with a TCP listener operates at layer 4 and does not terminate TLS. Instead, it passes the encrypted connection to the target. So this allows mutual TLS to be handled on the EC2, meeting this requirement. Basically, the encryption in transit. Okay, so the incorrect options. So configure an MTLS listener application load balancer. No, that's not going to work. That's a termination at the load balancer. Network load balancer TLS renegotiation. No, that's not going to work because the load balancer doesn't support MTLS at the load balancer level. And then TCP listener on an application load balancer. No, application load balancer doesn't support TCP listeners. Okay, so the TCP listener with a network load balancer, that's layer 4, and it gets that encryption in transit. Okay. All right. Cybersecurity company is using AWS Systems Manager Sessions Manager to manage EC2s on US East 1. Users unable to connect to a new EC2 that runs Amazon Linux 2 in a private subnet and a newly created VPC. The systems admin has confirmed that the new EC2 has the correct IAM instance profile. How do you attribute the root cause behind this issue? All right, so it's going to be D, okay, because you need this for private link, okay? It's going to be this, okay? You need this VPC, this Systems Manager, Sessions Manager for this endpoint, specifically for SSM, SSM messages, or EC2 messages, right? So this is for a private subnet. You have to configure the interface VPC with private link so the SSM agent can communicate with the systems manager without needing internet or net access. Okay. And since I think this is going to keep repeating, yeah, this is the same. This is repeating as well. I swear I thought I had this right. The network load balancer was set up on the company's infrastructure, but the target instances are not reaching insert. Yep, we just did this too. We just did this too. And we just did this one as well for the cache policy. And we just did this as well. All right. And then we just did this. All right, that's done. We're done with domain 3, at least my review for it. Okay, so a couple of things you want to be aware of, right? Really read the question, okay? Start to work the problems off that you can figure out are incorrect, right? Like, it just don't make sense based off what AWS has. So understand the relationships between security groups, NACLs, load balancers, traffic flow, right? Know the difference between basic and enhanced scan capabilities. Understand the KMS policies, right? What is that? What happens when you create, import, you're managing? If you're using customer managed or Amazon managed, what's the data recovery processes? Learn about systems manager, sessions manager, right? You're going to use that on the job. If you're in a very secure environment, it's great for you. How do you implement it? Why is it used off the public internet? How do keys work with it? Why does it replace? Learn about mutual TLS for encryption in transit. How does that work with application load balancers? How with network load balancers? And how does that actually get things done, right? It's critical to understand the distinctions between it and why they're used for passing encrypted traffic and how they do it, right? Learn about VPC endpoints for AWS services. So you're talking about private subnets with no internet And then what are you using versus a gateway endpoint? What is that actually connecting to? And then how do you distinguish that from NAT gateways or VPC peering or direct connect, right? Those are all very critical services you can use and you will use if you're doing this. And then KMS imports, we already talked about that. Access and control, right? So when we were talking about the file system, the EFS, think about how do you limit access through security groups, and then how do you limit authentication through IAM, right? Identity and access manager, because that's how you're going to manage that. And then cloud authorization. Okay, how do you forward authentication headers through CloudFront? Why would you do this? So it'll be done with cache policy. You'll have HTTP, HTTPS, and then this will allow you to have secure transmission. Okay. Outside of that, we'll get a couple more things. So I'll say, think about how the layers work. How do you meet compliance? What's cost and security? And how do those sometimes work against each other? And then how do you implement least privilege to get things done? All right, so next one will be identity and access management. But outside of that, thank you for joining me. Remember to like and subscribe.